So that's all for the part of runtime, and now we're going to jump into the number representation. So for number representation, we're talking about how to represent a decimal number in binary form. Or a decimal means base 10, and a binary means base 2. All right, so in base 10, you can use any number from 0 to 9. However, in base 2, you can only use 0 and 1. So how do we do that? So before we talk about negative numbers, let's think about the positive number first. So first, we will have a number, for example, let's say 1001010. All right, this is our binary number. And what is the representation in decimal? The way we do it is we always look at the rightmost digit, so this one. And starting from this one, it represents 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3rd, so on and so forth. So 2 to the 4 and 2 to the 5. All right. And the way we change a binary number to decimal number is just directly add all it together. So we have, in this case, 0 times 2 to the 0, plus 1 times 2 to the 1, plus 1 times 2 to the 2, plus 0 times 2 to the 3, plus 0 times 2 to the 4, plus 1 times 2 to the 5, which therefore gives us 2 plus 4 plus 32, which is equals to 38. All right, this is a quick example. Again, how to change decimal into binary. There is actually two ways. So the first way is to find the biggest or the maximum 2 to the n that is smaller than the number, than the decimal number. What do I mean? So for example, we have 38. We want to find the max 2 to the power n number that is smaller than 38, which by the calculation we find it is 32. Oh, sorry. It is 32 or 2 to the 5. If we know it is 2 to the 5, we're going to put a 1 at first, and this digit counts 2 to the 5. And then we have 2 to the 4, 2 to the 3, 2 to the 2, 2 to the 1, and 2 to the 0. And then we put a 1 here, and we subtract this number from the original number. So we have 38 minus 32 is equals to what? 6. And again, we repeat this step. So we find the max 2 to the n that is smaller than 6, which we know is 4, and 4 is 2 to the 2. So we're going to put a 1 on 2 to the 2, and we're going to subtract 4 from 6. We have 2, and then we're going to repeat this. The smallest number that is smaller than 2, smaller than or equal to actually, is just 2. All right? So remember, this is smaller than or equal to. And then we subtract 2 from 2, we get 0. We are done. So the moment we reach 0, we have a couple of 1s here. And then we're just going to put 0 on all the other digits, and that gives us the binary representation. So this is one way. And the other way is called the short division. And I find this way more appealing to myself, but there is a lot of people who like the other way. So just choose whatever that you prefer. What does a short division do? So short division basically says, I will put my 38 here, and I would divide it by 2 every time. So first I would divide it by 2. It gives me 19, and the remainder is 0. All right? So I'm going to put my division number 2 here, my result 19, and my remainder here. And I just keep doing this. So 19 divided by 2 is equals to, I know it is equals to 9.5, but we only want integers. So it is 9, and the remainder is 1. And then we divide by 2 again. So it is equal to 4. The remainder is 1. We just keep doing this. So we do 2, and the remainder is 0. We get 2. And we go 2, and we get 1. And the remainder is 0. The moment we reach 1, we stop doing this. All right? And all you need to do is to read this number from bottom to top. Therefore, if I read from bottom to top, I'm going to get 1, 0, 0, 1, 1, 0, which is exactly what we got here, as well as here. So this is just two ways that we want to change binary number to, or decimal number to binary number, and vice versa.